Okay, magandang araw sa ating lahat. Ang pag-aaralan natin ngayon ay patungkol sa uniformly accelerated motion. Ito ay tutor version ng ating topic tungkol sa kinematics. Now, uniformly accelerated motion is also known as kinematics equation. So, take note of this one. Pag sinabi natin uniformly accelerated motion, dito yung kinematics equation natin. Napakahaba ng definition ng ating libro patungkol sa uniform accelerated motion. Ngunit sa lecture na ito, dito sa video na ito, meron lang akong 3 punto na gusto kong malaman nyo. Pag sinabi natin uniformly accelerated motion, ang acceleration dito is obviously constant. So ilagay natin dito, pag sinabi nating acceleration or uniformly accelerated motion, acceleration dito is constant in the entire motion. Tandaan natin yan. And second one is, pag meron tayong acceleration, if acceleration is not equal to 0, ibig sabihin dito sa UAM, pwede rin natin kasi ito sabihin UAM para mas madaling banggitin, or uniformly accelerated motion, ang velocity dito is increasing. Velocity is increasing at a time. And pag sinabi rin natin kasing kinematics equation or yung equation na makukuha natin dito gamit sa uniformly accelerated motion, ito ay base or nakabase ito sa property ng ating velocity versus time graph. That means kinematics equation is based from or based on the property of velocity versus time graph. So ito yung 3 bagay na tandaan nyo pag sinabi natin uniform accelerated motion. Pero kung gusto nyo basahin yung definition talaga dyan sa libro natin, pwede rin. Pero ang bottom line nyan, sa hinaba-haba ng babasahin natin, ang pinaka-bottom line nyan ay pag sinabi natin uniform accelerated motion, ang acceleration dito ay constant. Ibig sabihin, hindi nagbabago. Yung uniform dito ay tumutukoy sa constant. Hindi siya nagbabago in the entire motion of that object. And yung velocity natin is increasing at any given time. Kasi pag ang velocity ay hindi nag-i-increase, meaning to say, constant lang siya, and we can say na ang acceleration natin dyan ay 0. But in this case, our acceleration is constant. That means this is not equals to 0. Na ibig sabihin yan ay velocity is changing or increasing. And property of kinematics equation can be taken from the velocity versus time graph. Now, para mas lubusan natin maunawaan yan, i-convert natin ito into mathematical expression para mas makita natin kung ano ba talaga yung ibig sabihin ng uniformly accelerated motion. So, assuming, halimbawa, meron tayong acceleration, sabi nga natin dyan sa definition natin, acceleration is constant, and let us assume na meron tayong acceleration of 3 meters per second squared, and meron tayong, sabihin na natin na meron tayong initial velocity of, shall we say, pwede rin 5 meters per second, at time is 0. Ngayon, intindihin natin muna itong acceleration dito. Ang sabi, ang definition talaga nitong acceleration, pag ilalatag natin ito, kung ano ba talaga yung acceleration na yan, yung 3 meters per second squared is also, pwede natin isulat as ganito, 3 meters per second. Ano ibig sabihin yan? ang moving object na merong acceleration or constant acceleration of 3 meters per second squared, ang ibig sabihin niyan, at any given time, nag-i-increase yung velocity natin into 3 meters per second. Yan ang ibig sabihin niyan. At any given time. At any given time. Halimbawa, ganito, para mas lalo nating makita. Gagawa tayo dito ng, lagay natin dito, ang acceleration natin is 3 meters per second squared. Tapos meron tayong initial velocity of 5 meters per second and meron tayong at t is 0. So ano para yung maipakita natin, gagawa tayo dito ng parang simpleng simpleng chart lang para mas makita natin kung paano or ano yung behavior ng ating velocity. So assuming ito yung ating time and ito yung ating velocity. So for example, sabi natin dyan kanina, 0, 1 second, 2 seconds, and 3 seconds. At time is 0, ito yung initial natin, 5, velocity is 5 meters per second. Now by the definition, nag-i-increase tayo at any given time, nag-i-increase ang velocity natin ng 3 meters per second. 3 meters per second. Ibig sabihin, at 1 second, magiging 8 meters per second na tayo dito, yung speed natin. Pagdating dito sa 2 seconds, magiging 11 meters per second na siya. And pagdating dito sa 3 seconds, ang velocity natin is magiging 4 meters per second squared and so on and so forth. Yan yung ibig sabihin ng uniformly accelerated motion. Nag-i-increase ang velocity natin at any given time doon sa rate ng ating acceleration. So kung nakikita ninyo from 0, the initial velocity 5 meters per second, at 1 second nag-8 naman siya, nag-plus lang tayo. Nag-add lang tayo dito ng 3 meters per second. So yan yung nakikita nyo ngayon yung kanyang sequence. So by that, pwede natin sabihin dito, pwede natin sabihin from this chart or table na at any given time, the velocity is increasing at assuming ito yung ating rate at acceleration or at 3 meters per second squared. Since ang acceleration is equals to 3 meters per second squared. So, yan yung ibig sabihin yan. Pag isubukan yung i-graph yan, magkakaroon tayo ng straight line. Pag susubukan nating i-graph yan. Now, let's go to ating PET simulator. Puntahan natin si PET simulator natin para makita natin to better understand kung ano yung magiging itsura ng graph natin. Kung ganito ba yung magiging itsura ng graph natin as kung ano yung nakikita natin dito. Base lang dito sa value na binigay natin dito. Kasi kung nakikita natin increasing siya, so magiging ganito yung parang prediction natin ng line. So we'll go to PET simulation at titignan natin kung ano yung magiging itsura ng constant acceleration with a value of 3 meters per second squared. Ano yung magiging epekto ng graph ng B velocity time graph natin. So nandito tayo sa PET simulator natin. Now i-adapt natin yung ating value doon na 3 meters per second squared. So ating acceleration is 3 meters per second squared. At this time, hindi ako maglalagay ngayon ng value dito. I don't care kung ano yung nandyan na value. Basta ang alam natin, pag sinabi natin uniform accelerated motion, constant ang acceleration natin. And this time, assuming na meron tayong 3 meters per second squared gamit yung ating value dito sa ating binigay na sample kanina. So 3 meters per second, ang focus natin dito na line of graph ay itong sa velocity. Never mind kung ano yung nandyan sa position. Dito tayo magpo-focus ngayon dito sa velocity. And titignan din natin kung ano yung magiging itsura ng ating constant acceleration. And we all know, di ba, that the constant acceleration, pag constant ang value ng isang acceleration or isang, shall we say, velocity, flat line lang siya, di ba? So, subukan natin i-play ito. So, kung nakikita ninyo, ayan, constant lang ang ating acceleration. Constant ang ating acceleration, ngunit ang ating velocity is increasing. Ngayon, nag-start tayo sa 0, at tumaas siya ng this rate na siya. Ito, 7.625 meters per second. At ito yung never mind yung value dyan, ito yung pinaka-importante na makita natin dito. Itong itsura ng ating graph. So kung napapansin nyo, yung itsura ng ating graph ay tugma doon sa ating prediction. Since kung babalik tayo dito sa ating table dito, ito yung prediction natin na if this is the case, kung ganito yung value natin, magkakaroon tayo ng graph na something like this, straight line. Yan. So ibig sabihin yan, pag ilalagay natin yung graph ng ating graph of velocity versus time graph when acceleration is constant. Ganito yung itsura ng ating graph. Ayan. So medyo hindi lang tayo masyado perfect line, but assuming na sana ma-illustrate natin ng maayos yung ating graph. So meron tayong ganito, if an object starts from something, halimbawa dito tayo, start tayo dito, magi-increase na yan siya at any given time. Magi-increase yung ating graph according to this value and according to our PET simulator dito. Never mind kung ano yung initial velocity na set natin dyan, but the thing is, magkakaroon tayo ng straight line na ganito na graph. So if that is the case, kahit anong initial velocity or kahit saan tayo mag-start at any given velocity, assuming this is a velocity of meter per second and this is time presented as second, kahit anong initial velocity natin, the graph is still straight line. Yan yung ibig sabihin yan. Ibig sabihin, lagay natin dito, increasing velocity but acceleration is constant. And ang makukuha natin dito, base sa graph natin, if velocity versus time graph, given that acceleration is constant, lagi tayong magkakaroon ng straight line na graph. So take note of this one. Now dito, kung napapansin nyo, kahit saan na pairs ng line natin or points natin ang kukunin natin dito, pare-pareho ang kanyang slope. Now, ibig sabihin, yung slope of the line dito, lagay natin dito, the slope of the line of the graph velocity versus time will give us the acceleration. Since slope is given by delta y divided by delta x, and in this case our delta y here is v and this is equals to delta b, and our delta x here is our time and this is given by delta t, and this is equals to velocity final minus initial velocity divided by the change in time. So this is our acceleration. Acceleration is equals to velocity final minus velocity initial divided by final time minus initial time. This is exactly, ito yung ating kwan dito, makukuha sa slope at any given points dito. Ang makukuha natin na slope dito is the acceleration for velocity time graph if the acceleration ay constant. Okay? Ibig sabihin yan, pwede nating sabihin na in kinematics equation, kung babalikan natin yung definition natin dito, kinematics equation is based on the property of velocity versus time graph. That means, kung gagawa tayo ng kinematics equation or kung susubukan natin i-derive ang ating kinematics equation, pwede nating sabihin dito mismo na ang ating equation number 1 ay ito mismo ang ating equation number 1 since ang slope natin dito from our algebra, di ba, that slope is given by mx plus b, or ito siya. Kahit saan na pairs ng points dito sa straight line natin, it will give us the same value of acceleration. Hindi ko na gagawin dito, pero pwede nyo pong i-verify yan, gamit ito. Try nyo i-graph yan, and from this, you set your initial velocity. For example, this is your initial velocity. And pag yan ang sinet nyo na initial velocity, yan din ang initial time ninyo. And pag ito naman ang sinet nyo na final velocity, ito rin yung initial velocity ninyo. I mean, this is your final time. And do the mathematics, babalik kayo dito sa value na 3 meters per second squared as what the straight line implies, na pag ang graph natin ay straight line, kahit anong pairs ng points dito, ang gagawin natin pag kukunin natin ang slope ay pare-pareho. So, ibig sabihin, pag straight line yan, pare-pareho lang ang slope dito. And yung slope na yan ay ang nagre-represent sa ating acceleration. So, by kinematics equation, pwede nating sabihin na for kinematics equation, ito yung ating equation number 1. Okay? Pag i-rearrange natin itong equation number 1 na ito, gagamit lang tayo ng medyo visible na color. Ang ating equation number 1 is given by acceleration is equals to final velocity minus initial velocity divided by sabihin na natin delta t. Yung delta t natin dyan is equals to tf minus ti. If we rearrange equation number 1 for solving velocity final, magiging ganito yung ating equation. So, if this is acceleration is equals to velocity final minus velocity initial divided by delta t, and this is over 1, pag i-rearrange natin yan, nung para doon sa medyo hindi pa masyadong gamay yung algebra, ito i-multiply natin dyan, and 1 times bf minus b1, bi, magiging bf pa rin siya minus b sub i. At ito naman i-multiply natin dyan, a delta t. Ngayon, we are rearranging yung equation natin based on this variable by final velocity. So, ito, ililipat natin dito. Ito para ito sa mga hindi pa masyadong gamay ang algebra, no? Kasi ang video na ito is a tutorial video. So, we are more on basic talaga dito. So, this is final velocity is equals to negative becomes, pag pinatawid mo dito sa tulay, this becomes positive. A delta t. So, by this, ito, pwede nating sabihin na ito naman yung ating kinematics equation number 2. Okay? So, balikan natin muna ito. Balikan natin itong graphs natin dito. Sabi natin dito na ito ay kahit anong pairs ng points dito ang gagamitin natin, the slope here is the same kahit saan dyan. Now, kung napapansin natin, no? Base doon sa ating discussion sa motion erase muna natin ito. Motion of graphs or graphs of motion na na-discuss natin doon. Nasabi natin doon na yung area under this graph, kung anumang graph yan, it can be a graph of velocity time graph, yung area dito, lalagay lang natin, ganyan. Yung area under this graph is equals to our displacement. Diba? Equals to our displacement. So, pag i-enlarge natin ito, gagawa tayo dito ng graph ulit. Dito na tayo sa next board natin. Kung gagawa tayo ng graph dito, using yung ating itong velocity time graph natin, velocity time graph, halimbawa, gusto natin malaman yung slope between these two lines here, 2 points here. So, draw tayo dito. Ayan. Draw tayo dyan. Now, remember that this is t and this is velocity. And also, meron din siyang corresponding velocity dito at any given time. Now, yung area dito under this graph is equals to displacement, wherein ito yung pagpalagay natin, this is our initial velocity and this is our final velocity, kasi itong vertical line natin is the graph for velocity. At dito naman is for time. So, ibig sabihin, pwede nating ilagay dito na this is initial time and this is our final time. So, pag susubukan natin i-enlarge, no? Itong section na ito dito, at dadalhin natin dito, meron tayong nabubuo na shape na parang something like trapezoid, maybe. Parang trapezoid siya. So, ayan. Palakihin lang natin. Now, dito sa trapezoid, sa ibang libro natin kasi, meron tayong mga libro na ginagamit nila is base dito, B2, tapos B1. Pareho lang yan. Mayroon kayong mababasa na libro na ganyan, but still, pareho lang yan. Depende sa orientation or depende kung ano yung gagamitin natin. Pero ang pinaka-importante, nandoon pa rin yung concept. Diyan sa libro natin, sa mababasa natin sa geometry natin, pag sinubukan natin baliktarin ito or pahigain natin itong trapezoid natin, magiging ganito siya. Magiging ganito. So, ito yung magiging kuwan natin ngayon. Magiging base natin ngayon. Pagpalagay natin, this is base 2 and this is base 1. Halimbawa. Ganyan yung magiging orientation niya ngayon. At ito naman, yung nandito is, yan naman siya yung ating height. Pero in this case, dito sa ating lesson, hindi ko i-adapt ito para hindi tayo magkalituhan. Gagawin natin na ganito, patayo na lang kung ano yung orientation na nandyan, ganun na lang yung gagamitin natin. So, ibig sabihin, ang gagamitin ko lang dito sa ating video ay yung nakatayo lang para hindi tayo nagkakalituhan since this is a tutorial video. So, again, ulitin ko lang. Papalitan ko lang yung mga variable, but ang pinaka-importante ay babagsak pa rin tayo doon sa formula of getting area of the trapezoid. So, gagawin ko, ito yung aking height 2. Ito yung aking height 1. At ito yung aking base. Now, kung napapansin nyo, no? Kasi dito, pag hahatiin natin yan dyan, pag magdodraw ako ng line dito, meron tayong again na parang right triangle dito. So pwede natin sabihin na itong linya na ito or itong portion na nandito is just be equals to ito. Kung napapansin nyo, ayan, papalitan natin siguro ng kulay para medyo makita ninyo. Ayan. Itong kulay na ito, or I mean itong side na yan is equals to our initial velocity. At itong side na ito is equals to our final velocity. At itong side na nandito is equals to our delta t, which is equals to tf minus ti or t sub I. That means, pwede natin sabihin na this is, ang height 1 natin dito is equals to b sub I, at yung height sub 2 natin dito is equals to b sub f, and yung ating base dito is equals to delta t. The area of a trapezoid is given by the equation of 1/2 height 1 plus height 2 times b, or pag ito yung gagamitin natin, this is area of a trapezoid is equals to 1/2 b1 plus b2 times h. Pareho lang yan. Walang problema dyan. So, as I said, ito yung gagamitin natin. So, para hindi tayo magkalituhan, erase na natin itong nandito sa baba. Itong nandito. Para hindi tayo malilito mamaya. So, ito ngayon yung ating gagamitin ngayon na equation para makuha natin yung displacement. Now, by doing that, this is, yung area dito is equals to displacement. Ibig sabihin, pwede kong ilagay dito sa ating, or i-substitute dito sa ating area of trapezoid, na instead of that, pwede kong ilagay si displacement. So, this is displacement or equals to x, displacement or x, or pwede rin natin sabihin d, or pwede ring s yan. Depende sa libro na ginagamit natin. But this video, gagamitin natin yung x. So, x is equals to 1/2 h sub 1 plus h sub 2 times b. And this is equals to 1/2. Yung h natin dyan, or h sub 1 natin dyan is equals to b sub 1. So, instead of h sub 1, kasi we are solving for the equation of itong displacement natin, ilalagay natin dito is b sub I plus yung h sub 2 natin dito is equals to final velocity, and this is equals to b sub f, close parenthesis, and yung base natin dito is equals to delta t. So this is delta t. Now the equation becomes x is equals to 1/2 times b sub I plus b sub f times delta t. At kung nakikita nyo, no, pwede pa natin itong i-simplify para medyo mas malinis yung ating equation dito. Pwedeng maging ganito. This is b sub I plus b sub f over 2, yung multiply this term dito, and times delta t. And this is equals to, x is equals to b sub I plus b sub f over 2 times delta t. Yung nasa loob ngayon dito, kung napapansin nyo, yung nasa loob, emphasize lang natin, itong term na nandito ay average velocity. This is average velocity. So, para makakuha tayo ng displacement, kailangan pala natin kunin ang average velocity with respect to time. And this is exactly the equation for solving the displacement of an object in velocity versus time graph. So, pwede nating sabihin na, anong equation na ba ito? Balikan natin yan. This is equation number 3. So, meron na tayong equation number 1. Meron na tayong kinematics equation number 2. Meron na tayong kinematics equation number 3. Now, moving on. How about if we multiply? If we multiply, kung nakikita niyo pag sama-samahin natin itong mga equations, makakabuo pa tayo ng bagong kinematics equation dito, additional kinematics equation. Now, how about if we multiply equation number 1 by equation number 3. So, equation number 1 natin dito is equals to, equation number 1 natin is equals to, balikan natin yung slide natin dito. Sana yung equation, ito, equation number 1 is equals to b sub f minus b sub I divided by t sub f minus t sub I. Now, equation number 1 natin dito is equals to A is equals to final velocity minus initial velocity divided by delta t. Assuming that this is equals to delta t is tf minus ti. At ang ating equation number 2, ilalagay lang natin dito is equals to, balikan naman natin yung ating, equation number 3, sorry. That's not equation number 2. Dito ay equation number 3. This is equation number 3. So, ang equation number 3 natin, babalikan natin dito. Ito yung equation number 3 natin. So, equation number 3 is equals to, equation number 3 is equals to, erase muna natin ito. Equation number 3 is equals to bi plus b sub f divided by 2 times delta t. A times, multiply natin into x. And this is equals to, for A, this is final velocity minus initial velocity divided by delta t multiplied to b sub I plus b sub f divided by 2 times delta t. And this is equals to b sub, ito, pwede natin i-cancel out ito, maybe, no? Nang meron tayong parehong terms dito, pwede natin ma-cancel out yan. So, this is equals to, para medyo ikuan lang natin, step by step natin, b sub f minus b sub I times b sub I plus b sub f over 2. So, this is equals to, ito, multiply natin dyan. Multiply natin dito, no? Para doon sa medyo hindi pa masyadong establish yung kanilang foundation sa algebra. And ito ay parang distributive property lang ito eh. And ito naman ay i-multiply natin dito. Tapos, i-multiply natin dito. Ayan. So, unahin natin yung nandito. B sub f times b sub I is equals to b sub I times b sub f. B sub f times positive b sub f, this is equals to b sub f squared. And dito naman tayo, tapos na tayo. Negative b sub I times positive b sub I, this is equals to negative b sub I square. Negative b sub I times dito naman sa b sub f natin dito. Negative times positive will give us negative. And this is b sub I, b sub f. So, kung nakikita natin, pwede natin ito si b sub I and b sub f dito. Cancel na natin yan. They will become 0. And ang natira na lang dito ay meron pa tayong nakalimutan pala, no? Nakalimutan natin this is still all over 2. So, sige, dito na tayo. Bali, ang natira na lang dito na term sa atin, since kinancel out natin si b sub I times b sub f, ang natira na lang dito is ito na lang. Ito na lang. So this is equals to b sub f square minus b sub I square over 2. This is equals to, kunin natin yan, a times x is equals to b sub f square minus b sub I square all over 2. So cross multiply natin, may 1 dito. Cross multiply natin yan. And ito, cross multiply natin din dito. So a times x times 2 is equals to, unahin natin dito na side. This is vf square minus b sub I square. Para madali na lang sa atin, hindi na tayo masyadong mahaba. Times 1 is equals to b sub f square minus b sub I square equals to ax times 2 is just b equals to 2. Unahin natin yung coefficient. 2 times a times x. And we will transpose this one dito para si final velocity na lang ang matira sa atin. So final velocity is equals to final velocity square is equals to b sub I square plus 2 times acceleration times x. Okay? Ito na ngayon yung ating, pwede nating sabihin na ito na rin yung ating equation. Ilagay natin dito. Pang ilang equation na ba ito? Equation number, pang ilang equation na ito? Equation number 4. Pwede nating sabihin na ito na yung ating equation number 4. What if kung, if we substitute equation 2 into equation number 3, and this becomes yung equation number 2 natin is equals to, balikan natin dito, ano yung equation number 2? So ito in terms of final velocity is equals to vi plus a delta t. This is final velocity is equals to b sub I plus a delta t. And equation number 3 natin is, ano yung equation number 3 natin? X is equals to bi plus bf divided by 2 times delta t. X is equals to ano yun? bi plus bf, b sub I plus b sub f divided by 2 divided by 2 times delta t. Sabi dito, i-substitute natin yung equation number 2 into equation number 3 and magiging ganito naman siya. So ang base natin dito is ito. Wait lang. I-substitute equation yung number 3. Isa-substitute natin yung number 2 sa number 3. So this is equals to x is equals to b sub I plus b sub f divided by 2 times delta t. And take note that yung final velocity natin dito is ito na siya. That means instead of using this one, ito yung gagamitin natin. Ito yung isa-substitute natin yung value dito. Ayan. So this is equals to b sub I plus, ito na siya, itong term na ito. Ang gagawin natin. This is equals to b sub I plus a delta t divided by 2 times delta t. Tama ba? Delta t. Okay. And this is equals to, lagay natin dito, this is equals to, substitute natin ito or distributive property natin ito. This is dito. Yan. Bibigyan natin sila lahat ng ganyan. Ng time. Ayan. So this is equals to b sub I times delta t plus b sub I again times delta t. Ito na siya. Then ito naman i-multiply natin dito. Ang ginawa natin dito, yung delta t, i-multiply natin sa b sub I. So magiging b sub I delta t, then plus, ito naman i-multiply natin dito. Magiging initial velocity times delta t, plus, ito i-multiply natin dito sa term na ito, and this is equals to acceleration delta t square na siya. Again, all over 2. So this is equals to, ito pareho sila ng term, kung napapansin nyo, no? Pareho sila ng term dito. This one. Pareho sila ng term. Ibig sabihin, pwede nating i-add yan, kasi pareho sila. So bi delta t plus bi delta t is equals to 2bi delta t plus, ito walang kasama yan, so kopyahin lang natin a delta t square divided by 2. And this is equals to, meron silang common, pwede pa natin ito in-simplify into, siguro, para mas malinis, no? Ito, pwede natin kasi meron silang common base na 2. So, this is equals, pwede rin itong magiging ganito. This is 2bi delta t over 2 plus a delta t square over 2. So, ito is makancel out natin yan. This is equals to b sub I delta t plus this becomes 1/2 a delta t square. At kung nakikita ninyo yung another equation natin is x is equals to b sub I delta t plus 1/2 a delta t square. So meron na naman tayong bagong equation. Galing dito sa equation number 2 at saka equation number 3. Pwede natin sabihin, pang ilang equation na ba ito? Equation number 5. Equation number 5. Pwede pa natin itong ituloy. Pwede pa tayong mag-derive ng equation. But siguro yung 5 equations na yan ay sapat na siguro yan para kung kung sa solving problem natin, yung 5 equations na yan ay malaking tulong na yan para madali na lang natin ma-solve yung problem or mahanap yung pinapahanap sa isang problem gamit yung 5 equations. Pero as you go along, pag magsusolve na kayo ng inyong sample problem, dadami pa yan. Madidiscover ninyo, from 5, dadami pa yan. Siguro magiging 10 pa yan or more than 10. So to sum up this one, mula dito, nakagawa tayo ng ating, nakagawa tayo ng kinematics equation. Wherein itong kinematics equation is the uniformly accelerated motion. Ano yung mga nagawa natin na equation? So we have equation number 1 of ano yung ating equation number 1. Ang equation number 1 natin is acceleration is equals to velocity final minus velocity initial divided by t. And equation number 2 natin, meron din tayong equation number 2. Equation number 2 is equals to equation number 2 is equals to b sub f, rearrange lang natin ito. So this is equals to b sub f, b sub I plus a delta t. And for equation number 3 is equals to displacement times b sub I plus b sub f divided by 2 times delta t. Ayan. And equation number 4. Equation number 4 is equals to b sub f square is equals to b sub I square plus 2a x. And the last equation na nakuha natin dyan, equation number 5 is equals to displacement is equals to b sub I delta t plus 1 plus 1/2 a delta t square. So, i-check natin. Acceleration is b sub f divided by delta t. Equation number 2, final velocity is equals to bi plus a delta t. Equation number 3, x is equals to b sub I plus b sub f divided by 2 times delta t. And equation number 4, b sub f square is equals to b sub I square plus 2ax. And equation number 5 is x is equals to b sub I delta t plus 1/2 a delta t square. Wherein, initial velocity or b sub I is initial velocity. And yung b sub f natin dito is final velocity. Ano pa ba? Yung delta t natin dito is equals to t sub f minus t sub I, or the time interval. Or sabihin natin, yes, time interval. Pwede rin, time interval. Or change in time. And ano pa bang nakalimutan natin? X. Yung x natin dito is the displacement. And obviously, we have acceleration. So, ano pa bang nakalimutan natin dyan? Initial velocity, final velocity, delta t, x, a, I think, nandyan na lahat. Now, SI units, wag natin kalimutan yung SI units kasi pag magsosolve tayo ng problem, ito yung basis natin, yung SI units. SI unit of this one is meter per second. Yung velocity natin dyan is meter per second. Yung time natin is small letter s or second. Yung displacement natin is meter. And yung acceleration natin is meter per second squared. So, ito na ngayon yung kabuuan ng ating discussion patungkol sa uniformly accelerated motion. Now, tandaan natin, sa uniformly accelerated motion, ang acceleration ay hindi nagbabago, pero ang velocity natin is nag-i-increase. And kinematics equation is based from the property of velocity time graph. At gusto ko lang i-emphasize dito, remember that, remember, in general, acceleration is changing.